you watch the videos? Wow.
Yes, teacher.
You watch the videos?
Yeah, you can put them.
Yeah?
You can put them. It will be okay.
Okay, this man is from eating some, I think, 1.5 plate. He's coming back. Okay. He's saying how good am I at fine art, but we don't use fine art here. I just put here heat. Some of you are drawing the what? The kitchen, and you're saying the saucepan is there inside. We can just put there heat, and then we shall have here, can have some molecules. Like that. Okay. You can put this. Wow. Sean. Sean?
Yes, teacher.
Hey, what was your question?
I was asking, there is some weird video I saw. A man put water in a balloon and started burning it, and the balloon did not burst. How is it so?
The balloon did not burst.
Yes.
So what caused it not to burst? Let us ask members who are around. Elizabeth. Elizabeth, why do you think the balloon did not burst? Elizabeth. Elizabeth?
Yes.
Why do you think the balloon did not burst? If you fill it with water? So let us try and label now. So this is if you get water, and you can try this, get water and put it in a cavera and heat the cavera, you see whether it's that. With a cavera, with a polythene bag, be burnt up. When you put water in a polythene bag and heat it, will it be burnt? Becomes more. So it does not burn up. The reason is that there is water and there is no air. You know that water is one of the fluids, or is one of the liquids that have We call it high specific heat capacity. So water takes long to gain heat. Water takes long to gain heat. That's why if the same thing, if you have a saucepan and you put water on fire, the saucepan will not be burnt. The same way how you have an empty saucepan. If you get the empty saucepan and you put it on fire, my friend, after something like 2 hours, you may find a hole in that saucepan. But the moment you place there water or you heat something, water which has a high heat capacity, specific capacity, it means that water takes long to gain heat. It takes long to gain heat. So that's why even the caviar will not be burnt, because inside there is a fluid that one takes long to gain heat. But you put there paraffin and you put it on the heat source, you will see. When you get a caviar and put paraffin and put on a heat source and you want to see whether the caviar will also, or the balloon will be heated, you try and you will see that the balloon will just catch fire within seconds. Shown, isn't it?
Yes.
So because water takes long to gain heat, and also what you have to know that water takes long to lose heat. And because it takes long to gain heat, that's why the caviar will not be burnt. So have you finished drawing that diagram?
Yes.
Very good. So let us write the explanation to that diagram. And the explanation is very clear. The way you see it there, the way you see it, you don't even change anything. You don't even change or do what. The way you see it, that's what we are going to write it, because I've seen it. So we should write that. That here. That here. Are you ready? So
Yes.
when a liquid is heated, comma, its particles or molecules, we can use particles, its particles closer to the heat source. Do you remember what I was explaining? Its particles closer to the heat source, gain energy. Can say gain heat what? Gain heat energy. Full stop. Gain heat energy. Okay, heat energy, comma, they gain heat energy. And after gaining heat energy, they do what? Expand, and become what? Become less dense, expand, become less dense, and rise. Full stop. That's what is important. Then here you can say that particles that are dense and cold at the top, move down. Move where? Move downwards. And replace the rising hot particles. So as a result, heat fluid moves upwards, and as the cold fluid moves downwards. As a result, heated fluid or heated water, we can say fluid moves downwards. Moves where? Downwards. Is that true? Is that true? Heated fluid moves where? Moves where? Moves upwards. Moves upwards as cooler fluid moves downward. Okay. Then they are saying this results in a continuous movement of water particles. This movement, so you can say that this process continues and this process continues with a continuous movement of particles called convection current. Underlying convectional current. Finished? Finished? Almost. So let us finish convection in gas in liquids.
Finished.
Okay. Okay, now we are going to look at an experiment to investigate convectional currents. An experiment to investigate convection in what? In liquids. An experiment to investigate convection in what? In liquids. Okay. So you are supposed to carry out this experiment at home. Yeah? You are supposed to do it at where?
At school.
No, at home.
School.
So what do you need? You don't need a plate, you don't need a fork. You don't need the... Okay, let us see. Let us see what we need. So write apparatus. Apparatus. Okay, let us first write. What is the apparatus? Which apparatus do we need? If you're at home, what do you need? Here they are saying a glass beaker or round bottom of the flask and straw. For you, what do you need now?
Saucepan.
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 Yes.
Will you be able to see the will you able to see the what? The convection currents going up and down using a saucepan?
A transparent saucepan.
A transparent saucepan. Have you ever seen a transparent saucepan? Okay. I think, okay, let us write. We need a glass beaker, isn't it? Glass beaker.
Who's that?
A glass. We need a glass cup, isn't it? A glass beaker, or you can use a round what? A round bottom of the saucepan, yeah? A round bottom of the flask. But we also a straw. We need a straw, isn't it? A straw you can get. So maybe you use the what? You use the glass cup, the small glasses, but they are likely to break. That means that you must use fire like a candle and then you put it at the bottom. Okay. We also need what? Potassium what? Potassium permanganate. We need potassium permanganate crystals. And also water. Now, what are you going to use in case you don't use potassium permanganate crystals? Members, what are you going to use? Think, what would you use?
Color.
Yeah?
Color.
Color.
Yes.
Use the
Dry color. Painting color.
Painting color. What do we use what?
Ink.
We use ink. Maybe. But ink is in liquid form. Okay, we use ink and we pour it in the, okay, we shall see. So we are going to use ink. And the other thing is that you have to be very careful. You have to be very careful. Okay, so what is our diagram? So we must draw there a simple diagram. The setup of our apparatus. So we are going to use, let us use in this case a round bottom the what? A round bottom the flask like that. Sean.
Yes, teacher.
You don't need to first practice and then you go to the campus and draw the round. No. You must do this with your. I wish I look what Ducky has drawn. Ducky.
Yes.
How are your diagrams? Let me hope you have not given your brother to go for you.
No.
But you have your brother there who's crowing. Okay, we have that, and this is heat. This is what? Heat source. So that's where we are going to put our heat source. So inside here we are going to put water. Now. So okay, first draw that diagram there. First draw that diagram. Put the water. Just put water here. So water is up to here. Okay. Now here we shall have crystal of potassium permanganate. This one is crystal. SR, crystal of what? How do they write potassium permanganate in chemistry? PAG.
K M N small n, and then capital O and a 4 down.
Like that.
Yes.
Good. You are just cocolastic. Not fantastic only. Manganese. Where am I coming for Christmas? Am I going to Shoni's place? Pav? Elizabeth?
All over.
Eh? So here we shall have what we call convection what? Convection currents of purple solution. And here we have water. And this is round D, bottom D, flask. Okay, like that. Do you have that?
Yes.
Okay, so I'm inviting everyone for Christmas. Okay?
Okay, at your home.
There is eating grasshoppers. The first to reach gets more. All right, so let us proceed. So what is our procedure? So who can tell us what is the procedure? What you tell me is what I will write. What should be the first thing? We are using the round bottom the flask. What should be the first thing? Okay, you are seeing it here. Put what? Pour water, isn't it? Not put. It should be pour water, not put, okay? Pour what? Pour some what? Pour some water in a round what? Bottomed flask, as shown above. As shown where? As shown above, not below. Now above, because for us our diagram is there. Okay, so we couldn't draw these kids. We had to draw what is important, only this. Okay, are you with me? Bridget.
Yes.
Okay, Bridget, let us proceed. What should be the next thing? Gently put some what? Gently put some crystals of potassium permanganate using a straw. Gently drop some crystals of potassium permanganate, onto the bottom of the flask using a what? Using a straw. So now for you are going to use a glass. Pour some liquid there and then use a straw and pour in small droplets of what? Small droplets of ink. I don't know what you should have used there in form of crystals. What should we have used? This is what we should have used, but I think these days we no longer use it. We used to call it bululu. Eh? You know what we call bululu? Eh?
What's that?
Yes.
Eh? Bridget, do you know what we call bululu? No one knows. It is something, it was a crystal that was used for washing clothes. So if you wash your clothes, it is white in color and you want it to have some kind of blue, sparkling blue, something like that. So you put in some crystal there and it changes the water into blue. These days they use detergents that are blue. Nambogo, do you know bululu? So you people are just born of this century, 21st century. Pav, I think Pav is even of 22nd century. Okay. From there, after applying using a straw and you have dropped some crystals of potassium permanganate. Yes, Catherine, we don't know. So what we are going to do is we are going to apply a small flame to the bottom. So a small flame to the bottom of our round bottom flask using a Bunsen burner or stove. So apply. You can say a small heat source, a small flame at the bottom. Okay, small flame at the bottom. A small flame at the bottom of the flask. Full stop. So we are going to write. Our next thing is going to be, what is going to be our next thing? Is going to be what? Observe. Observation. What do we observe? What shall we observe?
Crystals of the potassium permanganate going on top, rising.
So crystals, not crystals rise, but crystals of potassium permanganate, crystals of potassium permanganate dissolve. They first do what? They first dissolve. They dissolve and rise. And rise. And rise. Full stop. Full stop. That's what we shall see, isn't it? And then after some time, so after some time, comma, after some time, the dissolved crystals, after some time, the dissolved crystals sink to the bottom of the flask. Full stop. And this forms a purple what? A purple solution. Forms a purple what? A purple solution. So we shall see those crystals rising up, but after some time, they sink to the bottom of the flask, and this will cause a purple solution. So can we give the explanation? So you are going to give me the explanation. This one is going to be your assignment. You will give me the explanation why the crystals rise up and then afterwards they fall down, okay? And then they form a purple solution at the end. That way we saw that video, it was rising up, then afterwards they started falling down, and you are going to tell me why that happened. So you write it here and then you post it on WhatsApp. Okay, I know you get the answer here because they are saying from the above activity, convection current in liquids can be made visible in water in a beaker. On heating the beaker gently from the bottom, potassium permanganate spreads out and then descends to the bottom of in a cyclic manner. This is evidence that heat has been transferred from the bottom to upwards. Convection current will be seen as purple currents moving up and down. Alternatively, you can place a tablet of Panadol, very good, a tablet of Panadol at the bottom of the beaker full of water, gently heat the beaker directly below the tablet. And you see the observation, and you can also give the explanation. Are we together? Are we together, members? Are you eating? Is it time for lunch? Sean, is it time for lunch?
Yes.
Is it time for lunch?
Not yet.
Okay. So I'm leaving you with these questions. Write for me the explanation here. Are we together? And also you write for me the applications. Applications.
Of what?
Of convection in liquids. Liquids. You just outline them. Are we together? Sean? Sean?
Yes, teacher. Yes,
Are you
teacher.
going to look for the applications?
Yes.
You still, I asked Elizabeth. Elizabeth,
Yes.
are you going to do the applications?
Yes.
Dakia, okay, she's back. Pav, are you going to send? No. Pav, are you going to send?
Yes, teacher.
Are you going to send my work? Look for the applications, okay? Even Dakia, look for the applications of convection in liquids, and we just state them here like this, okay? So members, I would like our lesson to end here for today. Is it okay?